This is the first real proof that the CAD design of the Setka A can become a real structure. CAD design, CNC cutting sounds simple. But on an aluminium hobby CNC, and with me having to learn new skills along the way, the real question is, will this actually work? In the last video it took me the whole weekend to produce just one part. I had to figure out how to create simple toolpaths for the CNC, to plane raw wood flat, drill holes, create curved bevels and machine complex cutouts. We're working on this frame for the Setka, and the part I made in the last video was this deck beam. So now I'll add these to the stack. But first I'll have to finish the deck beam of the last video. I missed it on camera, but I broke my first bit in the machine because it ran into a screw. So let's fine cut the cutout for the top stringer. Since the toolpaths seem to work, I feel more confident to load a bit more stock on the machine and try to cut out 3 parts at once. So in Fusion I oriented the parts in this way, and I cut 2 pieces of Douglas fir where the grain orientation is the flattest on where the frame will meet the hull. Since these boards are far from flat, the first operation is to surface one side of them. Now for sure this hold down method with double-sided tape isn't optimal on non-flat boards. So if you have an idea on how to do it better, please let me know. After this operation, one side is perfectly flat, so here I trust the tape method better, but I still drill the dowel holes into the spoil board and put in the dowels before I do more aggressive cuts, like this first 2D contouring. In this rough cut toolpath, I left some material to do a finishing pass with a 2-flute compression bit, which leaves me with a nice surface finish. After that, I use the same bit to do the roughing for the beveled surfaces. After this rough beveling toolpath, there's a small ridge of around 1 centimeter left here. And of course I want the roughing toolpath to do the complete bevel all the way down. So at first of course I didn't understand, well, why would it happen? So I had to go back into Fusion to learn another thing. So for the bevels I used the 3D contour toolpath, and when we look at the settings there are many parameters which can be changed. So in my experience, the hardest part of all this CNC stuff is to find out what all these parameters do. The 1 centimeter ridge was caused by this setting in the geometry tab. It tells the machine to stay in the area of the actual part. So it was set that the center of the tool is allowed to move till that boundary. But to bevel this last part, the tool has to move past that boundary. So in this case, the correct setting is the tool outside boundary. Now to not repeat the whole cut, I'll set the height to start machining at 12 mm from the bottom. Now let's look at the result. Now this worked fine as intended, so to finish the cutting of these parts, I'll go over the bevels one more time with a 4 mm ball nose end mill. After that the parts are flipped and the cutouts are machined from the other side, since the router cannot reach every face from one side. Now the parts are finished and I want to dry fit them, so I'll cut an assembly board with the dowel holes to locate the parts in their exact position. So, the moment of truth. Will everything fit? I didn't try this before, for real, so let's check. Let's start with the bottom piece first. Port side. Starboard side. And now for the very first piece we made. Well, I don't know about you, but I am very happy with the result. Everything fits together very nicely. There's some minor imperfections, but this is a proof of concept. This works. So, frame E is there. The first part is marked. I'm ready for the next one.